The IEEE754 floating point standard is used to represent real numbers in computer memory. So the first bit is the sign, being 0 for positive and 1 for a negative number. Then you have 1 point, the mantissa. So to the right of the decimal point, you have the last 23 bits representing the mantissa. And that's multiplied by 2 to the power of the signed exponent. And it's the unsigned exponent that's stored in these 8 bits. So we'll call this EU. So a total of 32 bits is used to store a float or floating point number in computer memory. So the signed exponent, being 8 bits, can store numbers from -128 to 127. And note that 2 numbers in the signed exponent are reserved. So the useful exponents are from -126 to 127. And as we saw with the 2's complement representation, the first bit represents the sign, while the remaining 7 bits represent the number. But in floating point representation, the exponent is stored as an unsigned integer. So therefore the useful unsigned exponents are from 1 to 254, basically adding 127, where all of the 8 bits are used to represent the number. So with this example, we obtain the mantissa by shifting the decimal point in front of the leading 1. So what we get is 1.0010 by 2 to the power of 4, where binary is in base 2. So this here is the mantissa, and 4 is the signed exponent. And therefore to obtain the unsigned exponent, which is stored in memory, we just add 127 to the signed exponent, which gives 131 in base 10. So in binary, the unsigned exponent is 128 plus 2 plus 1. So this unsigned exponent is stored in memory. And we see that this number here is positive, so the signed bit is a 0. And given that the mantissa is 0010, that's stored in the final 23 bits, and the rest are filled with zeros. So to convert back to our number, we have 1 point, the mantissa, which is 0010, 000, and the rest zeros. And that's multiplied by 2 to the power of the signed exponent. So the signed exponent is obtained by subtracting 127 from the unsigned exponent. So here we get 131 minus 127, which is 4. And therefore, this is 10010. So in base 10, this number is 18. Please subscribe, like and comment to help me reach more students.